tend to use the formulas on the board, because if I put the calculator step on the board, it really doesn't mean a lot if you don't use the calculator. It's kind of a glare today. Better? Okay. So in a survey of women ages 20 to 29, their mean height and their standard deviation is given to us. It probably does say it's normally distributed, otherwise we wouldn't be able to use it. I probably just didn't write that part. So those two pieces of information are critical. Pull those two pieces out. What height represents the 95th percentile? That means you're taller than 95% of the people. Ladies, your area, your percentages go from here to 100. From the left. This is very, very critical. From the left. Our goal today is to find those X values. To find what value is that cutoff. That's our goal today. So I need to know how much area of the curve is to my left or to my right, whatever they're looking for. So in my calculator, I need to find my z-score that represents area to the left. 95% of my curve sits to the left of me. Inverse norm, 0.95. Make sure you put it into a decimal, because one of the characteristics of your curve is that the area adds up to 1. So your calculator can't do it if you give it a percent like 95. It needs to see 0.95. I find the z-score associated with that. Remember, our curves are a little exaggerated, so where we're looking like, oh, this doesn't look like it could be 1.645 or 1.65 or 4 or whatever you put it, we'll see why those are longer in a minute. But 3 decimals, 2 decimals is fine on your z-scores. If you use your formula, this is given, this is given. This is what you found in your inverse norm. If you did 1.64, if you do 1.64, 1.64 is 5. That's 2 decimals. And just round. Remember to round into your shading. If it's shaded to the right, round into the right, round up. If it's shaded to the left, round down into your shading. But you need to be in that shading part. If you're looking for the first quartile, well, how much is a quarter worth? 25 cents. So I want the first 25%. I want to come out 25%. This is 50 from here to here. I want to come out 25%. So I do an inverse norm and I find the z-score that corresponds to 25% coming from my left. This is the important part. Again, if you do this on your calculator, let's put this part in your calculator. This one's nice in your calc. Second bears, come to inverse norm. If you're looking for 25% and you want your z-score, standard deviation is 1, mean is 0. It finds your z-score for you. If you want to go right to your x value, just come down here and now plug in your area. That stays the same. Plug in your mean. Your mean was 64.2. And what was your standard deviation? 2.9. 2.9. Plug this in here. It bypasses finding the area. It bypasses that z-score. It cuts right to the x value. It gives me my x value right away. Here's my x. They're a little bit more exact in your calculator. So in your calculator, it's 62.24. But you're going to tell me calculator. Calculator says bypass this whole thing right here. But you still need to know this part. You need to know where your area is coming from. Because if you put it in the calculator wrong, you get the wrong answer and you get no credit. Because I don't see it unless you write me the steps that you put in. Which everybody doesn't like to sit and write the steps that they put in. But if you put in 0.75, it's wrong. And using your calculator, that's a trap of your calculator. I won't see it. I won't be able to see that. Questions at all? Questions? No? Stop me if you have any questions. average time spent sleeping for a group of medical residents at a hospital can be approximated by a normal distribution. We can use our normal curve for this, with a mean of 6.1 hours and a standard deviation of 1 hour. So we draw out our curve. That's important. I need the sketch. What is the shortest time spent sleeping that would still place a resident in the top 5% of the sleeping times? Top 5. It goes from 0 to 100. Where do I find the top 5? To the right or to the left of the mean?
To the right.
To the right. Somewhere up here, I want this to say 5%. I want to find that cutoff spot. So I first do inverse norm on this. My cutoff, if you want to say 95% to the left, or have a couple of choices. You can say 95% to the left. You subtracted it yourself. Here's the 0 and the 1. Paste it. Ladies, there's my z-score again, 1.64. If you want your calculator to subtract this for you, by all means. If I'm 5% to the right, tell it. I am to the right, 5%. Can you please subtract this for me? And now let it do it. And you don't have to subtract. You do have to convert to decimals. But it can subtract it for you. If you use this and then put your mean and your standard deviation in there, you can do it still either way and put your mean and your standard deviation in. That is fine. So we find the z-score associated with that. Again, use your formula. This is your standard deviation. This is your mean. Your z-score, if it's positive, will add to that. Your z-score, if it's negative, will cause that to subtract it by the negative number. So your formula works out really, really nicely. Try to round this to the same decimal that your mean is rounded to. So you could round this to 7.8. Wait, we have to round into. So remember to round up into this. Even if it was 4 or 5, we would still have to round up on this because you want to round into your shading area. The middle 50%, what two values? This is a good one. What two values does the middle 50% mean? Here's, let me put it over here. My middle 50%, that means this has to be 50%. In the middle, exactly in the middle, because your curve is symmetric. So that has to be where your middle two values are. This z-score and this z-score will be the same number. This one will be negative. Okay, so you have a couple of ways you can do this. If this is 50% in the middle, and this whole curve is 100%, these two pieces have to add up to 50%, don't they? Isn't that what makes it 100%? So if I need to know this one, what's half of 50? 25. There's my 25%. I need to know my z-score up to 25. Then I need to know my z-score up to 75. But if I look up my 25, isn't my 75 the same thing but positive? So I look up my z-score, and I get a negative 0.67, so I know my other limit, my other boundary, is positive 6.7. It's symmetric. 50% has to be equal distance in the middle. So I plug them in, and I can find my two x values. Now your calculator, if you do this on your calculator, you've got to do it twice. This doesn't have that in-between thing. Everybody get this one? This is a little tougher to get. Are you quiet because you don't care? Or you didn't get it? Or you did get it and you don't care about that anymore? I don't know. Tell me, guys. Talk to me. Are you getting it? All right. The annual per capita consumption of fresh apples in the United States can be approximated by your normal curve with the mean and standard deviation. What is the smallest per capita of apples that can be in the top 25? Top 25. It means I have to do a 1 minus 0.25 or 0.75. Plug it in, get my x value. Bottom 15%, bottom 15 is nice. It's coming from the left. Area is always to the left. So 0.15, I just plug it in my calc. Inverse norm, 0.15. As you can see, these are the critical parts. These are my critical parts. The rest of it fits right into my formula. Makes sense. That's why I like you to shade. Make sense of this. So the top 25, we looked that up before. We just looked that up in the last problem. If you already looked up your z-score for the last problem, top 25, right? Because we had 25 on the bottom, 25 on the top. Don't even look it up again. You know it's 0.67. You know what that is. And look up your bottom 15% and plug that in. Make sure you round. Make sure you round your z-scores to 2 decimals. Don't give me 1 decimal place on those z-scores. I'm going to start taking points off. 39. The weights of bags of carrots are normally distributed. Good, we could use our curve. The mean of 32 ounces and a standard deviation of 0.36 ounces. That standard deviation should be small, right? Because if you think about it, if you're going to buy one of those little bags of carrots, you don't want that standard deviation. Well, me as the manufacturer or the producer of that, I don't want a large standard deviation because I'm going to either lose money if I'm giving them too many carrots, or my consumers are losing money if they're not getting enough carrots, right? So you want that standard deviation to be small. Bags in the upper 4.5 are too heavy. That means I'm giving my consumer extra carrots, right? Me, the producer, says, Notice he cared about the heavy bags, not the lighter bags. So the consumer kind of gets screwed on those lighter bags, but the producer of this does better when he gets rid of those heavy bags. So he says, they must be repackaged, they're too heavy. I'm giving them too many carrots for their money. So I want to know, where is my cutoff? What is my weight measure for that cutoff? 4.5% has to be turned into a decimal. Same way you would 4%. You would take this and move it 2 decimal places. Even though this has a decimal place, you move it 2 decimal places. So you're looking for your area to the right to be 0.045. Your inverse norm has to say this. If you looked up the 0.045, you're going to get a negative. Then just turn it into a positive because your curve is symmetric. You can't do that, though, if you're using your x values in there, if you're using your actual mean and standard deviation. You have to use the correct one. Let your calculator do the subtract. So any bag that's greater than this amount, that's greater than 32.6, let's say, 32.7, whatever it comes out to be, I'm going to take this off the shelf and repackage this. I'm giving my consumer free carrots. It's costing me money. By the same token, he should take the 4.5 off the other side, since now he's not giving them enough carrots, right? But as the producer, I don't care about my consumer as much. Okay. You sell a brand of automobile tires that have a life expectancy normally distributed, mean of 30,000 miles, standard deviation of 2,500 miles. You want to guarantee free replacements, and this happens. This is how they work this. For tires that do not wear well, you are willing to replace approximately 10% of the tires. Where are you going to replace these? 10% when they drive over what you thought? Or 10% when they're under what you expected? Under. You, the consumer, feels real good when you drive 10% over. You did better on your tire. But 10% here, you didn't even make your mean yet. You didn't even get up there yet. So they're going to look for the cutoff for the lower 10%. You kind of have to figure that one out. Like, I'm not going to complain when I drive more than my mean says, right? I've got more than my 30,000 miles on this car. I don't care about this side. I care about this side. Hey, I didn't even get 27,000 miles. You told me I was going to get 30,000 miles. That's what your consumer cares about. So you're looking at your bottom 10%. So bottom 10% says, where is my cutoff? Find me your z-score for your bottom 10. Plug it in. sense, right? Are there any questions? No? Right, you're going to have a little quiz on this tomorrow. Just a short quiz. I like to do this